Good morning. Here we are again. Our topic today is science and society, and we're going to get into things like what is a scientific theory, what is a scientific law, why does it matter, what are facts, and how does science help society. So I have some notes I'll go through here with you guys. So our topic is science and society. And we're starting here with the difference between a scientific theory versus a scientific law. So here's just the definition that I've developed over the years. This is maybe one of the most important definitions you need this year. So theory, as you guys know, has a societal kind of everyday usage. I have a theory of who left the cabinet open, that sort of thing, but that's not a scientific theory. A scientific theory is an explanation of some sort of natural phenomenon based on scientific observation and experimentation that is predictive. So that means it has the ability to be useful and tell us something that's going to happen in the future, and is also falsifiable. So what does that mean? Falsifiable means that the theory could be modified or changed in the future as new evidence comes to light. Theories should also be testable. That is a critical thing, because where does science come from? It comes through experimentation. So let's start by looking at a couple of theories. Our first example is the theory of plate tectonics. So this diagram should look familiar from earth science. The theory of plate tectonics is a theory that explains something. What does it attempt to explain? Well, it explains why there's volcanoes and earthquakes at predictable places around our planet, and we base this theory off of scientific evidence. We can actually measure the movement of these plates every year using GPS satellites. And it's testable and also falsifiable. What does that mean? We could maybe modify our theory as we learn more in the future. Here's another theory that you're probably familiar with, the heliocentric model of our universe. It explains something. What does it explain? It explains how the sun is at the center of our solar system and the planets orbit the sun. It is based on observational evidence. It is testable. It's predictive. We can say that the Earth will go around the sun next year. It's also falsifiable. What if we describe the orbits in a more precise fashion using complex math, that sort of thing? So as you ask yourself, is it a theory or is it a law? You want to get in the habit of asking these same questions that I've been asking. So the theory of plate tectonics was a theory. The heliocentric model was a theory. And I'm sure you can come up with some other examples of theories, and we'll probably talk about that a little bit in class. So what's a law? A law is a rule of nature. So usually expressed as an equation. And an example of that would be the famous equation E equals mc squared. And the person who came up with that, as some of you probably know, is Einstein. And what that equation stands for is that energy is equivalent to the mass of an object or particle multiplied by the speed of light squared of that particle. And so that's kind of just a description of how nature operates. It's not really explaining anything. It's not predicting anything. It's just describing what we see in this universe. So laws are usually going to be some sort of mathematical relationship like that, or maybe gravity, for example. And so there's definitely a difference between the two. Most science is elevated to a theory at its highest point. You might think theories aren't proven or that sort of thing, but an accepted scientific theory is about as good as science does. And then laws, most of the laws regarding our universe have already been discovered or described. So science should be based on facts, another key idea. And so what is a fact? This is an important thing with society as we argue about how science should inform policymakers and what's true and what's not true. And in the simplest sense, if science is done in the way it's supposed to be done, that the scientific results are based on these things called facts. So what's the definition of a fact? A fact is simply an indisputable truth. So something that would be agreed upon by all parties all the time. An example of a fact might be the fact that I am recording this video right now. That's a fact. Or another fact might be the fact that I'm alive right now. And you can, I'm sure, come up with some facts that if somebody denies a fact, that doesn't make it not a fact. It just means they maybe aren't aware of it, or maybe they're not intelligent, or maybe they are blind. I don't know. But in today's world, there's a lot of kind of an attack on science, and that it's not factually based, but that's exactly the opposite. Science is factually based, has to be peer reviewed, which we'll talk about in a little bit. So how does science help society? There's a nice kind of graphic I want you to copy into your notes that illustrates the role of science and how it helps us as a society. This process of creating scientific theories and doing experiments and tests, and what's the whole point of it? So what you can see here on this chart is we have 4 corners to this square. We have societal issues, we have develop technology, build knowledge, or inform policy. So in the middle of this square is science, and science is kind of interconnected through all of this. Remember, science is this problem-solving process which is based on the scientific method. It answers questions by doing experiments. Why do we care? Well, let's start up here. A societal issue that we might have. A problem in society. Let's say that problem might be the current wildfire situation in California. How can science help us understand that societal issue? Well, it certainly can. We can learn about how increasing forest fires are related to climate change. We can learn about how forest fires are related to fuel loads in the forest. Science can tell us all sorts of things about this issue. So what do? Well, let's go over here. We can develop technology to help us fight these fires, perhaps. Some scientists are known as engineers, who they develop, design, and build things to help develop technology to deal with our societal issues. And that technology could be, a fire retardant, for example, or it could be a software chip. It could be really big, could be really small. How does that relate to building knowledge? So, well, technology is related to knowledge. Where does our knowledge base come from? Generally, the process of doing science. So some science, maybe it's not solving a problem, or it's not developing technology. We just want to do it so that we know. And sometimes we don't have any questions until we kind of know more. So just doing science for the sake of building knowledge is a pursuit that happens a lot of times in college research facilities. And then over here in the farther corner is this inform policy bubble. How does science help us inform policy? So this is like, well, what should we do about these fires? What can be done? Well, first we have to understand what the problem is, and then we have to understand, based on science, what some possible solutions are. And hopefully the people in charge will use scientific based solutions to address these problems. And why should they do that? Well, because science works. It's gotten us to a place in this world where, we have a computer basically that's handheld, which can do amazing things and is light years beyond the computers that I grew up with. And all that came from studying science and developing technology. So science, it can be changed or modified, but generally speaking, science works. And this process that we've developed is pretty useful. So we want to make sure that the people in charge are using the best science available to make their decisions. Hopefully that helps build your understanding of where does science fit in the role, the context of society. Thanks for watching. See you in class.